Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. And part of programming an engine, which we do since we're doing everything from scratch. We have everything from the very lowest of low-level codes to the highest of high-level bits. Well, shouldn't say high-level. We have all the code. You can assign whatever level to it you want. But part of that is definitely debugging and performance analysis. And one of the things that we wanted to do now that we sort of have our basic stuff all working, is we wanted to get some visibility into how the code works. So we're making a little debug system where we can annotate our code with some markup. And then while the game is running, it will display for us a bunch of information about what it's doing. And we've done a bunch of work to record that information, but we haven't done too much work to visualize it. And that's sort of what we want to work on today. So today's a coding day for sures. So it's day 184. If you want to follow along at home and you pre-ordered the game, take a look at day 183 source code, unpack that to a directory. That's what I'm starting with here. So if you want to follow along with what I'm about to do, that is the source code with which to start. Now, where we left off is we had the platform layer and the game together running through the same debug system, which is nice. Even though they're on either sides of that DLL boundary, they're running together, which is great. So you can actually see it all happening here, right? And we're sort of getting a bunch of readouts. These are the functions that are all there. Some of them are in the platform layer, some of them are not, et cetera, et cetera. And so what we'd like to do now is we'd like to start working on how we can actually view this information in a way that's going to be, you know, more exciting. Right? We'd like to be able to do something where we can explore, we can investigate what's actually happening in a way that doesn't involve us trying to make sense of just a giant tableau of numbers, which, you know, admittedly would be pretty hardcore of us to do, but why do something ourselves when we can program a computer to do it, right? That's kind of why we program computers in the first place. So what we're going to do today is start looking at how we could sort of collate this information and sort of use it in a way to make something more accessible and more readily understandable for us so that we can explore it easily, right? So what I'd like to do is start by having, going back to kind of that concept that I had before, where we've got sort of a bar chart thing so we can see on every frame what the bar breakdown is. And then I want to be able to do something where we can sort of drill down into it, right? So we can kind of drill down into the bar in some kind of a way. So we can start by looking at what's taking the time very quickly at a glance and then sort of refine and refine downward to sort of get more of an opinion about what is going on. Now, there's some tough parts about this, obviously. And I'll just briefly mention what they are. And we're going to have to try and kind of maybe think about what the best interface would be in terms of being able to visualize that stuff. So let me just quickly say what that is. Here's day 184. And this is like perf counter visualization, right? So one style is very, very simple for us to do. Well, I shouldn't say very simple for us to do. I mean, we had to do a bunch of work, obviously, to collect all this stuff and all that. But so I'm not going to say simple or complicated. All I'm saying is it's pretty straightforward to envision. If I have something that's like, you know, a graph of the time where I've got some different things and like, you know, routine A, B, C, D, and E are all represented here. And these are like the 5 top level functions of the program or whatever they get called. Then if I want to investigate one further, I could click on it or something. And then it would open up that and show me what its breakdown was, right? Like what were all the things that took time for it, you know? And the problem with this is that let's say there's some common thing, right? So let's say that I do that for D and I also do it for A, right? And then I've got in here, I've got, you know, F, G, H, I, J, K, and then here I've got L, M, G, N, O, P, right? When I look at D and when I look at A, what I will see is the fact that G, the function, is not taking an appreciable amount of the time necessarily, right? It's not like I would single that guy out as being like greatly more than anyone else on here. But if I start seeing this G in a lot of places, then I'm like, oh, it actually turns out that in aggregate, G is taking a lot of time because it's taking a bunch of time from D and it's taking a bunch of time from A and maybe it's taking a bunch of time from E and so on. So we kind of need two ways of viewing things, right? We kind of want to be able to know two sides of the same question. We want to know hierarchically who's taking the time. So if we're trying to optimize D and we're thinking about D, we want to know how much time G is taking up of D potentially. So that's one thing we might want to know. But we also might want to know how much time does G take up of the frame in general without having to drill down all the way to every single one of them and then mentally try to add up in our heads how much that is. That's no good, right? So I feel like we kind of want two ways of viewing it. We want one way, which is sort of like, we want one way that's hierarchical, right? So we want like a hierarchy view, which is this kind. But then I think we also want a like top slow people or something, right? Something which then says, okay, I don't care about the call graph. I don't care who calls who. It don't matter. All I want to know is this routine, whatever this routine is, I want to take how much time it spent, say, exclusively of its children. So I'm not going to count its children. I'm just going to count the time spent in that routine. And I want to know, sort like all of the functions and put them in here, right? Or something like that. Or you don't even necessarily have to sort them, just draw them all in the bar graph, and the ones that don't take up any time will be tiny, and the ones that take up a lot of time will be big, or something. Right? So that's what I would like. That's what I would like to see. And I think that that's probably good enough at the moment, is just being able to view it in these two different ways. So I'd want to be able to like pick between those two, and that really be it for now. Okay, so that's what I'm going to try. I'm going to try to make something that works like that. So let's just get started, right? Let's just see what we can do pushing towards that. And that'll be the goal for next week, is getting a nice view thing in. So today we'll just get started on that. So if you only have one day, before the end of the week, we're not going to probably get that far, but we'll just do what we can. So here we are in the debug code. And we have sort of our collate debug records thing. I'm pretty sure update debug records is not used anymore, right? Like we don't even do this thing at all. So I'm just going to go ahead and delete that, right? It never gets called by anyone. It's old. And so what we'd like to do is kind of revamp what we're doing here. We've got these get hex things. What is that? Oh, this is for that sort of weird debug text line thing where I indulge people's fantasies of weird text on lines and stuff like that. All right, so I'm going to skip that stuff for now because that's not super relevant. So what we have here, we've got these debug statistics. I don't know that I super care about those debug statistics at the moment. So I'm going to leave them. I mean, there's nothing wrong with it as it is, but I don't think we care about that too much. So in the debug overlay, I'm just going to start here, and I'm going to sort of pretend that we can kind of do whatever we want to do here. I'm going to pretend I have whatever I want, and I'm going to draw it as if I had the data structures I want, and then I will go like reverse engineer essentially what those data structures would have to be, and then I will make the collation functions make them for me, right? That's my thought on that. So what I want to do at the outset is I want to have two modes, right? I said I wanted two modes. So I'm going to want like one mode. Well, I'm drawing a bar graph, but I have two sources for the bar graph. So I might just say that I've just got the bar graph. So maybe the collate, whatever the collate does, produces a structure that I can walk that is what the bar graph should look like, right? Something like this. And so what I'd do is I'd say, okay, instead of any of this stuff, I don't even know, I don't want to really know what this does. I don't care. I'm just going to like get rid of it temporarily. If 0, yeah, I don't care about any of that stuff. That's going to go away for now. So I'm going to come in here, and I'm going to say that yeah, I'm going to say that this is essentially going to run very similar to the way that it ran before. So we've got, the settings here. We have like how high the chart's going to be. This is all, can just remain the same because we're just making that chart, right? Then we've got this snapshot index thing, and it's going to run over however many of these we want. And again, the snapshot count, I think, at this point is now going to mean something slightly differently. Really what that's going to do is like the frame look back is what that's more going to mean, right? How many frames of look back we have. And so these snapshots and stuff, this is not going to be a meaningful thing anymore. And I'm going to kind of get rid of that temporarily, I think. Debug state, debug counter states. Yeah. Yeah. In fact, this stuff doesn't really even need to be stored over time, but that's a separate issue. All right, so what I want to do here is I want to say we've got some number of frames, right? So we've got frames from 0 to something, which is going to be like something in a frame count. So this is going to be like debug state frame count or something like that. And then for each frame, I'm going to go grab whatever that frame is. I'm going to say debug state frames plus frame index, like so. And then inside here, I'm just going to go ahead and do, like, for the frame, I'm going to say that there's like some number of elements in the frame, right? And I will just go frame element count, and I will, what did I call those before? Well, they were events. I guess it's not really. So it's not really an element. It's more like a region index. Let's call it a region index. I feel like a region index is good. Region index is good. Okay, so that sounds all reasonable. Yeah. Okay, and so the scale here, we're going to have to work on the scale a little bit. Talk about that in a second. So when I come through these regions, I have a debug frame region. I'm going to call that region. I don't know what it means. I'm just drawing it, right? Because I'm going to use the same bar chart drawing code regardless of which of the view types. Remember I said I kind of want hierarchy and top people. I don't want to have to like write two paths of code for the same thing. So I'm just going to say that I just don't know. So I've just got region. So whatever the frame is, it's regions plus the region index is going to get me out whatever that region was, right? And so that's fine. And then in there, I will have something that will tell me how big, this thing was supposed to be. If that makes sense. So there is sort of one additional factor that I'm not sure how I want to handle. And that is also the fact that I kind of need these things to be able to support, I suppose, multi-threaded sorts of stuff. So I'm not sure how I want to do that. Like, if we were single-threaded, we can just use the bar. But if we're multi-threaded, we really have kind of like multiple tracks, right? So a single bar, you could almost think of as having like multiple tracks. So in there, you might have a thing that was like doing this sort of nonsense, where you sort of have like this thread is doing stuff, and then I guess we would, we'd want to have sort of a notion of when a thread was not doing anything, so we could mark it as not actually being used or something like this. But there's definitely sort of this notion that when in trying to give like a nice coherent snapshot of what's happening, it's a little bit tricky because you can have sort of multiple different regions of the code being active at the same time because there's multiple processor cores that could be executing those regions. So I'm not sure exactly how to handle that. Maybe I'll just do it by segmenting the bar, if that makes sense. That seems like probably the right thing to do. But I don't know, it might be too much information kind of crammed into one space. Maybe the smarter thing to do is to have a different chart per processor or something like this. But I feel like you kind of want to see them on there. That's just my thought. Just so you can have sort of that quick visual idea of what's happening per frame. And we don't have to have that many frames of lookback actually displayed. Like, we might want to store 60 frames of lookback, or however many we can afford to store without taking up too much memory in the machine, right? Maybe we store that many, but that doesn't necessarily mean we have to show that many, so we could make the bars fairly thick, right? We could make the bars be fairly thick as they go across, and at that point it would be pretty easy for us to show more in there. So I think I'm going to just try that. That's going to be my first sort of thing that we try. So I'll do something like, you know, channel width or something like this, or like core width or something like that, lane width maybe. And the lane width is going to be, let's say, 4 pixels or something like that, or maybe it's 8 pixels. Maybe it's how wide it was before. And then the lane count is probably going to be something that actually comes from the debug state. So we'll just say that there's a lane count that's set there. And so the bar width is whatever the lane width is times whatever the lane count is, you know? And so we come through here and we say, all right, that then gives us what we needed to know, which is, you know, how big the chart should be and all that stuff. And the bar spacing should really be based on the bar width. So it should really be the bar width plus however much space we want in between bars. So we can leave that as something like that. So there we go, chart height, chart width. That stuff all stays the same, I think, and that looks fine to me. The scale, again, is something that we would need to worry about sort of separately. I think that might be something that we want to put in here, right? So we'd have like a scale value in there, and I don't know what we'd want to call that. We want to call that like the frame bar scale, right? And this, I guess, would be the frame bar lane count. Something like that. Okay. So this is going to be the frame count. And the rest of this is pretty similar. So we come in here, we've got the frame, we've got this stuff. We don't need the prev seconds anymore. We're not doing that kind of diffing or anything like that. So in here we can just say, oops, close that out. In here we can just say, okay, we've got the colors. We take a look at whatever the region index is, I guess, and we just use that color so that we just try to alternate colors as much as possible. Even though we really don't know exactly what's going on there. And so, you know, we also kind of want to know, we kind of want to do these per lane. I feel like we kind of want to do these per lane. I'm not sure. I'm not sure how to do this part exactly. We'll see. So I don't know how to grab out the color because I don't really know. I mean, I guess I could use the lane index plus the region index or some weird thing like that. But I guess we'll just use the region index for now. And we'll see what we have to do to make that work. In terms of the proportion, what we need to do is just take whatever the thing is, you know, the proportion, the height, this sort of stuff. We need to basically say that whatever the region is, that's going to have the information in it that we need to figure out where we're at. Now, it's worth noting that all of this stuff is pretty much constant, right? So this is going to be like a stack x sort of value, I assume. So we can just do that, right? Where we can say, okay, we've got where we should be on the x for this bar. And then all we really have to do here is add in whatever the lane index is. So wherever this is lane index-wise, that's going to have that lane width added to it, right? So that way we can kind of move the thing over. So that should be it for that. And then the bar width, instead of being the whole bar width, is just the lane width now. And in fact, I guess this is also just the lane width now as well, right? So that's good. So all we really need to do is figure out what the height is, I guess. And now the problem is our stack y is actually going to be whatever the excuse me, the max debug lane count is, I suppose, right? So whatever the lane count is for these bars, we need to keep a separate stack y for each of them. Does that make sense? Because as we stack those things up, we kind of need to make sure of that. Now, I suppose we could force the calling code to sort things into lanes, but I don't know. Like I said, we can make that decision later, I suppose. So we can go through the lane index to be like whatever this is, I guess array count stack y plus lane index. So we can make the stack y for all the lane indexes start out at the min, and then we would always just increment whichever one the lane index tells us to increment, right? We could always just make it go up. I guess the other thing we could do is just store, if we're going to know begin and end times, we could just store those in there as well. I'd have to think about, I guess there's really no reason not to do it that way. Because then we wouldn't need anything, right? Then we wouldn't need this at all. We'd just use the chart min, like so. And we just have it so that the region itself has its min and max. So essentially what we do is we'd say, you know, this y and this height, it's just going to be, or this min y and this max y is just going to be the stack y plus whatever our scale is times whatever the region's min y was. And then this one's going to be the same thing, plus the scale times whatever the region's max y was, right? Or max, I don't know what we want to call it, max p, I guess, because it's not specifically y or anything else. So max t, maybe? I don't know. So whatever we've got there should be sufficient, because then the thing can just put regions wherever it wants to put the regions, and it has the ability to kind of represent that data in as so much as it needs to. And so yeah, then we just add in that lane index, and that all looks like it would be pretty sane. And then we don't care about this, and we just have to make it use these. So it would be, in order to get the center of that, right, all we do is we do this min y plus this max y. That would give us the center. And then the lane width, lane height thing, we now know that the height is just the max y minus the min y, right? So that should draw the chart, right? I mean, that should do it, I would think. So yeah, that looks good. So at that point, I think we have the drawing down, and now we just need to figure out what that would actually entail. So inside our debug state, what that suggests is what we would need to store is these sort of debug frame region things, right? Debug frame region. We need to store those regions. We would need to do a debug. Let's see. We had debug frames. And is that it? That looks like it. We just need to store those. And so those, debug frame region, those are going to be exactly what they imply here. So we know that inside our debug frame, we know that we've got a region count, we know, oops, we know that we've got regions. We know that there's nothing else at the moment. So then we've got the region, the, oops, put that in the wrong place. We know that we've got the region. That has a min t and a max t, and also a lane index. Yeah. So doesn't look like it has anything else, does it? That looks like it for now, just for the drawing purposes. So yeah, let's see how that goes. So if we were to do this thing, where is the what is the debug state situation? Where does it even get that? It just gets it from here, right? Yeah, it does. So these can just be this kind of nonsense, right? I think that's true. In fact, these can actually just be pushed and popped onto there, I think. That's probably safe. Because that's our memory, right? We can do what we want to do with it. So we can probably just say, all right, we've got the debug state. It's just got a pointer to the frames. The frames have pointers to the regions, and everything's fine. And this stuff is just, we don't even care about this stuff at all. In fact, can we get rid of this at the moment? Is anyone going to complain about that? All right, so our debug state needs to have a few things added to it. It needs to have the lane count. It needs to have the frame count. And it needs to have the frame bar scale. And now it does. When we're doing collation, we don't actually want, I think, to do a lot of this stuff at the moment. Actually, I'm going to just turn this off for now because we need to rewrite this function to produce the data we actually care about. So we don't actually care about that at all. Counter count. All right, so this stuff is all pretty much done as well. Okay. So I think that should give us what we want for the drawing routine, and it's given us the specs. So I think all we have to do now is actually fill it out, because obviously it's not going to do anything until we fill it out. So all right, let's go ahead and make a collating thing that will actually fill that out to some degree. Yeah. Okay. So I don't really remember how our debug storage stuff was working. I'll be completely honest with you, I have absolutely no idea. So how was that working? These are the only two places we actually get it, when we call the overlay and when we update the records. It looks like that's the case. So I think that's just how it goes. Apparently. Yeah. So that means we can just full on use this as a scratch pad every time through. We can just go ahead and recreate it, and that is fine. So that's good. That makes it really easy on us. Our work is simple. All right, so yeah, let's go ahead and do that. The way we would do that here is by just using the, I just use the mandala system for that, right? I just use our arena, this stuff. So I think what we would want to do there is inside the debug state. Who initializes the debug state might be one thing. I guess it never really gets explicitly initialized, it's just initialized to 0. So presumably what we want in here is something that sets that to 0, right? So in here we have something like, initialized, and that gets set to 0 normally. And so in here we just go like, assuming that we have a debug state, if debug state initialized is not set, we know we've got to do some work to get things up and properly initialized. And so in here, what I want to do is I want to get a memory arena that's our debug arena, and we'll just call this, you know, whatever this guy is. It's going to be probably like our collation arena. So what I'll do there is I'll initialize that arena like we do everywhere else, right? Let's see where that comes in here. Initialize arena. So when we come in here, I will initialize that arena, debug state collate arena. I don't even know if I'm spelling that right. I don't know how many L's does collate have. Should we just ask that question? It was 2. Good. I win the spelling bee. So how about that? So for now, I don't know how much space we want this to have. I suppose we can just use whatever the storage size is minus the size that we already took for the debug state. I suppose we could just do that. And maybe later we'll decide we need to parcel this out differently, but for now that's probably fine. So then we'll just say, okay, it's whatever the debug state plus 1 is, that's where we'll stick this data. So now we just have the ability to kind of like allocate whatever we want to allocate inside our debug pool, which is what we want. So that gets us started. And then what we want to do, I think, is we want to have a temporary memory, right? A begin and end temporary memory sort of thing. And so what I'm going to do here is just say begin temporary memory, and I'm going to begin that into the debug state like collate temp. And the idea here is every frame, I'm just going to rewrite all this memory every time, because we're recollating like everything basically, which I don't know how, like, I don't know if we want to try and do something cleverer than that. We probably should, but for the moment I'm not going to, just because it's going to be a lot harder to do it that way. So if it turned out that this was somehow fast enough, we'd just use it this way. It probably won't be, unfortunately. But, you know, we'll start this way, and then we'll look at, okay, now we got to do something a little more clever where we, you know, only collate incrementally or something like this. Anyway, so if we do our collate temp and we do begin temporary memory, then what we can do is every frame here, we will just go ahead and do end temporary memory and begin it anew. Like so. So that's all I'm talking about. Something that allows us to rewrite everything. Every frame, it just kind of vaporizes the thing that we had before. And that, get rid of this. Yeah, no, I'm not. And that is all I'm talking. That's all I was trying to say, really. So Handmade debug needs to be able to use that stuff, and of course it's up here. So I need it to kind of be a little bit below this stuff, which is a bit of a problem actually, to be honest with you, because the memory arena stuff, we want to add debugging into there as well. So it's kind of tricky, the fact that these things want to also be defined. So I'm literally just going to move just these above there, because I want to leave everything else below it, I think. That's my feeling. That's my feeling on that. I don't know how you guys are feeling about that, but that's just how I'm feeling about it. I feel like it's important. So that should do it. And then I'm going to go ahead and call this collate debug records thing. I'm going to initialize these other things. So yeah, so this stuff should all be set to 0, I think. I'm going to say debug state frame bar lane count equals 0. Debug state frame count equals 0. Debug state frame bar scale equals like 1.0 or something equally stupid, or 0. And then I'm just going to call collate debug records. Maybe I'll even put that in there. Maybe we'll say that it looks like that. Who knows? All right, so when I call collate, and I call it with the debug state and the events and whatever, that puts me in a good position to like start setting this stuff up, right? I think. Right, that's all good. And so now we're running just fine, and in theory we've got that memory that's kind of like sitting there being ping-pongable for debug, and that's all good too. So now I just actually have to do some work here to actually produce some type of collation for these guys. Now the way that I had it set up before, if you remember, in platform.h, I've got basically a set of arrays of these values. Right? So every time we have a debug event, what it's doing inside this debug table is it's going ahead and like putting it in here. And every time we go to like read stuff out of the debug, we flip that event counter. And now that I think about that, and I am thinking about that, now that I think about that, it seems like the more intelligent place to do that is at the frame marker. I'm going to leave it like it is. Anyway, so when we come in here, we've got this array of events, and these actually go in order. And in fact, in some sense, this was stupid. I don't know why I kept that code in there. I was like, oh, I should keep that code in there, but that was actually not true. Because what I actually want to do in the collate debug records is I want to actually look at all the events. So what I actually want to pass to collate debug records is I actually want to pass to collate debug records what range of events it should be considering when it is considering the events that it considers. And in addition to that, I need some way of storing how many of those there are. So in here, I also need something that's like event count, right? And I need the same of here. I need the same in each of these. So we need something that's like here as well, max debug frame, or max debug frame count, something like that. And that's in here. So then, when we come through here, every time we have the end of an event, every time we have the end of a notification on the end, I'm going to know how many events we had, because it's this right here. And what I need to do is I need to store that piece of information. So whatever the event array index was at the time, I need to go into the global debug table, take the event count there, right, and set it to what I now know the event count to be. So it's actually, just keeping track of that as we go, because otherwise we have no idea how many actually got filled out in there. Yeah? So, yeah. And it also brings up the fact that really we could just have pointers into that thing. It doesn't matter, but there's other ways we could have structured that as well. It sort of starts to become clear like how things could be done. I don't know that it's necessarily any better, but it's like, okay, there's some reasons why you might do it a different way. Anyway, so when we go ahead and do the rest of this stuff, when we call collate debug records, what we want to do now is say, okay, I know what event array index we just ended on, right? So this is the one that's done. So I need to pass that to collate debug records so it knows that everything other than the one that's right after that one is the one that we could do, right? So I'm going to pass it the one that we just finished, and then also the one that is now being used, right? In fact, that's probably just the thing to pass it, is just global debug table, whatever the one is that you no longer can use, it needs to know that. And then, what the heck, I'll also pass the one that's just finished. So inside here we would say most recent event array index, and here's the one we'd say invalid event array index. Okay? And so what that's doing is I'm saying I have essentially what is a circular buffer of event arrays, right? Each one of these things is like an event array that has like tons of stuff in it. And what I'm saying is, all right, I just got finished writing this one, right? So that's, I want to know which one that is. That's the most recent. Yeah? And then I have one that I'm writing to. This one right here. And so you can't use that one. That one cannot be included because some, like a variety of different threads could be writing to that right now while we're using something else. So what we want to do is we want to assume that the one immediately after that one is the one to start with, and that we would eat all the rest of these up to the most recent one. So that's how we want to process these event arrays as we go. Hopefully that makes some sense. If it doesn't make some sense, well, sometimes programming just doesn't make sense. I mean, what are you going to do, right? I think this is actually going to be a while loop. I think, possibly. No, you know what? It could be a for-i loop. So I'm going to go event array index. I am going to start, just like we said, with whatever the one right after the invalid index is. So this one right here. I'm going to start with that one. I'm going to say if the event array index, well, I guess I should also, I have to do the wrap. Maybe I can roll the wrap in there, though. You know what? I think it's going to be a while loop. I think it's going to be one. So we'll just do, or rather, one of these like infinity guys. So I can do this in here, but I'm not going to actually have a condition for exit. Right. So plus event array index is in there. And the condition for exit, unfortunately, I can't actually write in there. And you'll see why. It's because whatever it is that I'm here, I have to first check to see if the event array index equals the max event array count, right? So whatever, no, I didn't put that in there. Whatever this is, if it equals that, then I have to set it to 0, because that's a wrap as it increments. And then I have to check if it equals the invalid array index at that point, then I would break, because that means I stepped past the most recent one. So again, this is why I was saying we really only need one, which is the invalid entry index. That's the only one we actually need. And so what I could do is just say, yeah, don't bother passing this one. Just pass whichever is the one that you can't use right now. So that steps through all of the event arrays, right? So we're guaranteed to visit them all, and we're guaranteed to visit them in the order of oldest to newest, which is what we want, because we want to go in temporal order, right? Okay. So now, inside each of these, we now need to loop over all of the actual events that they have, because each one of these has events. So each one of these can have max debug event count events, like so. And we need to take a look at what each of them does. So each one of these debug events can be accessed pretty trivially. It's just going to be the global table, events, event array index, plus event index, and then we have the event. And the event, of course, has all of this information in it. And really the thing that we care about here is the type. So we need to take a look at what the type is, and we need to do whatever it is we're going to do based on what that type is. Okay. So we see the event type, and we take an action. And again, we know that we are now seeing the events in their order, roughly, from earliest to latest. Now, on any given thread, we know that they're definitely from earliest to latest. But when multi-threaded is taken into account, We don't necessarily know that exactly. But we do know that for the most part, they happen in the buffer in order. I just don't know how serialized RDTSC is in that sense. I suspect on the current processors it's pretty darn serialized. But that's kind of a separate issue. So as we come through here, obviously when we hit a frame marker, we know we're going to kind of latch over to a new set of bars, right? If that makes sense. So every time we see those, we're going to switch over to like a new set of bars. So we had the idea there of that being like frames. We had this concept here of a debug frame. And so we kind of have this concept of debug frame, current frame. And that's going to be like the very first frame. And so what we need to do there is we need to have a way of like doing, a next frame or something like this. So that when we come in here, or like an add frame, so that when we come in here and we get to a frame marker, we can just move to like the next frame. You know what I'm saying? Something like that. And then in a begin block and an end block, we need to be able to use that debug information that we have here to sort of see what was going on. We don't actually know a core index at the moment, but we do know a thread index. The thread index is not necessarily numbered in a way that we want, so we would have to look it up, unfortunately. But that's just kind of the nature of the beast, if that makes sense. Also, there are ways we could probably make the threads be a little more be numbered sequentially. And that would be to use sort of Windows declared thread local storage or something like this. But since we don't know that we can necessarily count on that on all the platforms, and we might want to have our profiler work everywhere instead of just on Windows or something like that, I don't know. We might want to have the lookup sort of be based in here, right? So when we do a begin block or an end block, like either of those two things, we're going to be doing more or less the same stuff. In fact, to some degree, we may want to sort of have like, we might want to kind of have this stuff be relatively pulled out here, right? So maybe at the top, before we switch on the event type, maybe we do some stuff here, right? Like so. So in order to pull out the proper debug record, that should actually be relatively straightforward, right? Because that's just going to be whatever the... oh, look at that. There was a record count. Oh, no, that's a record count. I was going to say, not the event count. It's like, it was already there, but that was a different thing. Totally fine. So we would just do this, right? We just do the thing that allows us to go from an event to the source for whatever it was. So that's the source. And it's got the translation unit in there, and it's got the debug record index, which is what it uses to figure out which one we were looking at for the source. So now we know both the debug record and the event, both. Hit count, cycle count is not a thing anymore, right? So I don't even know why any of that's there. I have absolutely no idea. That's just garbage at the moment, I guess. So we've got those two things. And then we got to look up some of this other stuff. So we have the clock, but that's not particularly relevant to us at the moment. So we should look at event clock in a second. But then we've got event thread index, and what we want to do is turn that into a lane index. So we want to do something like get lane from thread index, or something like this, right? The core index at the moment we're just going to ignore because we don't even have a way of getting it, unfortunately. And we've used these two. So that just leaves us with the clock. And what I would argue as far as the clock is concerned is until we you know what, in fact, this is true. Until we actually see a frame marker, we probably just want to throw away all the events. Because we don't actually have any way of knowing how much of a frame we're seeing until we actually see a frame marker, right? So we actually want this to be 0. So at the outset, we just throw away events. We just throw them away until we actually see a frame marker. I think that's probably what we want to do. That seems likely to me. And so as we come through here, we just do something like, okay, when we get an event, well, okay, we'll do it a little bit. We'll take it one step at a time. But point being, when we have the current frame thing, we could then say that the frame, that frame structure, we could say that that has in it the clock, the initial clock, right? In fact, it could even have like a begin clock and an end clock, because we actually know what those will be after we've sort of looked at this stuff, right? So what we can do there is say that we have a relative clock, right? And the relative clock is going to be whatever the events clock is minus the current frame's begin clock. That's the relative clock for this event inside the frame, right? Pretty straightforward. How much time I got left? 5 minutes? That was the 5-minute warning, yeah? Okay. Then we've got the lane index, which we're going to get from somewhere. And that would give us what we need to know. Now, like I was saying, I think we want to make sure that we kind of guard this stuff off. So this stuff will work no matter what, but this relative clock thing will only work if we have a valid current frame. So what I think we want to do is do something like if event type equals debug event frame marker, then we do whatever has to happen there. Otherwise, we just do here a switch on the event type. And if there's not going to be that many event types, honestly, maybe we don't really do anything else here. Maybe we just make this be event type equals debug event begin block, else assert event type. Well, you know what? I'll just, for sake of completeness. Okay. I like how that completed to nothings. Found in handmade.cpp. Is that from the fountain? Awesome. There you go. All right, so begin block, end block, it's all good. Everyone is happy. Everyone is smiling and excited about life. And so then I can just put that stuff in here, right? And I know that I have a valid current frame in that case. So that's good. So in here what I'd do is I'd have the new frame thing. And that's going to equal however we get a new frame, which we'll work on in a second. And then what we'll do is say, okay, the current frame's end clock is going to be equal to whatever the clock was here. Yeah. The regent count, well, is just whatever it is at the moment. So that's pretty much finalizes that frame, right? In fact, we can just do it like this. And then we can just say, okay, then current frame equals however we get the new frame. And which will be trivial. In fact, I already know what it is, actually. It's just going to be, right? It's just going to be frames. Frame count. There it is. Frame count. Debug state. Frame count plus plus. So the current frame is just going to be equal to debug state frames, and that just gets a new one off of our thing. This one is going to say, okay, assuming that there was a current frame, we set its end clock. Once we have a new one, we want to set its begin clock equal to the event clock, and its end clock equal to, I don't know what, probably some kind of value that lets us know that it hasn't had an end yet, and then its region count is going to be equal to 0. All right. Seems fair. I'm going to go ahead and compile this just to make sure that it's all kosher. Looks like it is. And we'll make it not implemented for this. Inline get lane from thread. There's the thread index. And we will, I assume, also probably have to do something where we've got like a debug state here to pass that. And for now, we'll just return 0 and say to do implement thread ID lookup. Okay. So we're getting there. We got a ways to go before we have all this sorted, but we're getting there. And I think next week we'll be in very good shape to make that happen. It is extremely hot here at Handmade Hero Studios. I probably shouldn't be wearing a sweater. That was a poor choice of garment, it's true. But poor choice of garment or no, I'm going to go to the Q&A anyway. So if you have a question, please go ahead and post it with a Q colon in front of it, and I will attempt to answer it. AndSZ says, you could have made your loop this way for U32 event array index equals invalid event array index is 1. Event array index is not equal to invalid event array index. Event array index equals is max debug. Yeah, I did want to save the modulo, which is why I didn't do it that way. It's probably not a big deal anymore, right? Like, some of those things are kind of habitual that there's really no need to get out of the habit of, so I don't. But it's true that a lot of things like modulo are not really a big deal anymore. But it's like part of, you know, growing up with a certain set of things being expensive. Like modulus is very, very, very expensive in the old days. You would tend not to use it unless you knew that the compiler or you could optimize that modulus to something else. And so I still tend to not write things that way. I tend to write them in ways that don't require a modulus when I know that one was not necessary. And I suspect that that's something that people nowadays probably don't do. Like people who grew up programming, you know, over the past 5 years was their first experience of programming or something, are not going to be afraid of modulus, right? They're just going to throw it around. And that's fine too. But it's definitely something that I avoid in cases where there really was not necessarily a need to avoid it. Like, is it going to be a huge problem to have a modulus in this loop? I don't know, but probably not. I wasn't in my head thinking, oh my god, modulus is going to be a problem. It's just I tend to avoid it. Chrono Dragon says the chat was a bit distracted. It happens. Elvin, what would be the most important things you'd look at when hiring a programmer? What type of questions would you ask? Does he have to have like 20 plus years of experience? If I was going to hire a programmer, I don't know. That's a good question, and it depends on what I would want them to be doing. If they're supposed to be programming in parallel with me, meaning they're going to go do something while I'm doing something, then yeah, they would have to have 20 years of experience, probably. If it was the case that I was going to have somebody who was kind of going to be like a utility programmer for me, where it's like I'm programming stuff, and then I'm just telling them, I want you to go make this thing for me right now, and then like at the end of the day you give it back to me, then that would be someone who I could hire, who I just thought was a good programmer. Like I was like, okay, this person's pretty good. They don't maybe have very much experience and don't necessarily know exactly what they're doing all the time, but like it's okay because I'm going to sort of like drive that process, and they just need to like not make code that's bad. which is itself a tall order, but they don't have to have 20 plus years of experience because I'm not expecting them to make decisions. I'm expecting them to, if I make the decision, be able to execute that decision. And that's a very different thing. And so, I don't know, these days, the way I would probably look for hiring a programmer like that is now that people are streaming programming, I just say, I want to see your Twitch streams. I want to see you program on Twitch, and I'm going to watch them. And if I watch them in a while and I think you know what you're doing, then I'm okay with that. If not, then I'm not. Because that's way better than anything else. Because there, at least now, I see how you're programming. I can watch you program for a long time, not in some weird interview setting. You're on your computer with your editor, doing code you feel comfortable with, and then I can watch you, right? So I'd probably be like, show me your Twitch stream. If you don't have a Twitch stream, I'd be like, well, why don't you have a Twitch stream? Get a Twitch stream and then call me back. It don't got to be public. You could have it be private, and you don't have to talk. You can just code, like Pseudonym73 does. And then I'd be able to see, right? Gary Johansson, do you think you do not need to ever worry about modulus or divides anymore? It's not that you don't ever have, there's nothing that you don't ever have to worry about. It's more just like, in the context of what we are doing here, the amount of like data that we're spinning through and the amount of operations we're doing are probably such that one modulus per loop iteration is just not going to add up to very many cycles by comparison to the total number of cycles for the loop. Whereas in the old days, when you were talking about like everything, you know, might have been like 1 or 2 instructions that you were doing, but a modulus took like 40 or more, and memory accesses took like 1 cycle as well, or something like this, right? That was a big deal. Nowadays, a modulus doesn't take nearly as long as a cache miss, right? So it's just a different set of trade-offs in your head. So habitually avoiding modulus is definitely not like it used to be. It doesn't mean you don't have to think about it, because just like everything else, it costs something. But it does mean that thinking about it as this big scary thing doesn't really need to happen anymore, because it's not any more scary than a bunch of other things that I don't avoid, right? So that's really more what I meant. Which Linux debugger is closest to not sucking, and what is it missing? I don't even know, man. I don't know. I don't have a good answer for that. I really don't. I wish I did, but they're all pretty bad. I don't know. Original name 667. On a scale of 1 to Visual Studio, why is Emacs a 1, and when will you join the Visual Studio Master Race? So, not to be too brutal about it, but of the good programmers I know, I can only think of one who uses Visual Studio. Only one. And he is somebody, it's Sean Barrett, and he is somebody who has in the past used DOS command line edit for editing and been fine with it. So I don't necessarily tend to take his opinion of editor particularly seriously, or his selection. Other than him, I literally know 0 good programmers who program in Visual Studio. There probably are some out there, but none of the ones I know. They all use something else. Emacs is not particularly good, but it's a lot better than Visual Studio, because Visual Studio is pretty bad. It's better than it was. Well, it kind of got better and then it got worse, but it's still pretty bad. Sorry if this has been asked before, but what keyboard are you using? This is a DOS Keyboard 3, which unfortunately I don't know if they even make anymore. I liked the DOS Keyboard 3 a lot. I don't like the DOS Keyboard 4, so I'm kind of been looking for a new keyboard, a new go-to keyboard. I just ordered, actually, on someone's Twitter recommendation, a Razer Black Widow Stealth, and I was going to try it out. So I don't know how that's going to work, but I'm still trying. I tried a Keyed Up Labs one, and it was a really well-made keyboard, but just the keys were too darn stiff for me. How did you get into game development? You know, there's a big, long story about that. If you're interested, I think, gosh, I think it was like all the way at the beginning of Handmade Hero. Let's see. I don't know if the annotated episode guide has it in there. It might. So in the episode guide, it might be here, but I'm not 100% certain. No, it's not. It's not there. Oh wait, it might be in the Q&A. Yeah. So here it is. So you can go right here for that, actually. This is it. So Intro to C on Windows Day 5 Q&A has it. And if you use the episode guide, you can get the little time markers. So if you go to What's Your Life Story, that tells the whole story. It's like a half-hour long, and it has the whole situation. It's kind of a weird and twisted, odd path, certainly. It's not like I woke up one day and was like, I'm going to be a game developer, and then went out and developed games. Steven Last, my girlfriend wanted to let you know that she has the same water bottle as you. Well, that is both good and bad for your girlfriend. Good because I feel like the glass bottle is nice for taste. I feel like things taste good in glass to me. But you know what the bad thing about these is this right here. This is a bad design all around. It's very hard to make sure it's actually sealed properly. I have to like turn them over and shake them in the sink to make sure they're sealed properly, because the sealing onto the glass is often fraught with peril and it won't get on there exactly right. And then the other problem is this part tends to break. I've had the rubber break like on here for me. So I'm not a huge fan. It's close to what I want, but it's not there yet. They need a better top. If they fix the top, then this would be like my favorite water bottle. But until then, it's got problems. If your girlfriend ever finds a better water bottle that's glass, please tell her to let me know, or you let me know, one or the other. What decision process do you use to choose the color of sweater to wear on a particular day? It's whatever is like in the top of my laundry basket. Because when I take the clothes out of the dryer, I just put them in I have like a few laundry baskets. I just take them out and I put them in whatever like bin I have available, and then I just take clothes off the top of it. Slim Seer, will you please sign the contracts with Twitch so we can get good Casey emotes in chat? Next time I talk to Twitch, I will ask them. Elvin, have you seen the poker keyboard series? It's very interesting in that it has all the keys in the center of the keyboard, and you never have to leave the center row. I don't know what that is. I have not seen it. Stephen Less will keep you updated. Thank you very much. CX00, still using the 3-bin system for clothes? Yes, I am. Elvin, does it ever happen to you when you sleep on a problem and then wake up with a solution, which is click in your head? Yes, that happens to me all the time. I've often said that it's important to make sure you get a good night's sleep, because I feel like you do a lot of programming problem solving in your sleep, if you're anything like me anyway. So yeah, it's a good thing to do. I highly recommend making sure that you get a good night's sleep, and let your brain have some time to like work on problems. Like my pocket theory for like how brains work is that at night they do a lot of intentionally random neuron firing, which tries to build. It's like basically like if you've ever seen a rapidly exploring random tree, an RERT, like daytime is the drive to point phase for concrete ideas, and then sleep time is the drive to point for random ideas. So like during the day, you are trying to get your brain to like build a path to a particular solution of some kind. And at night, what it's doing is it's randomly going to places, so that when you wake up, the neuron paths are already built there for those states, so that they're just there all of a sudden. And so when you go to think about the problem again, you find, oh, there's one right next to it, and I can just hop right to the solution from there. Right? So it's like, I feel like it's one of these things. You know what I'm talking about? And so, like during the nighttime, you are essentially building new random paths onto your random tree, so that like when you wake up in the morning, you're like, I'm trying to find a solution that's like out here. During the day, like you couldn't get to it, but then after a night's sleep, it built all these extra ones for you, and so then like right there, it's like, oh yeah, it turns out it's like right next to something. I can totally see how to get there, and I'm done. Right? Let's see. Does it have to be at night or just when you're sleeping? I don't know. I'm not a neuroscientist, so this is just my theory based on what I've observed myself, how like it feels. So it's not really a science. So I have no idea. It's just a purely random theory that has no data to back it up, other than anecdotal. All right, I gotta wind it down. I gotta go soon. What time do you usually go to sleep? 10:30. I usually wake up at 7. Could you please expand on what you meant by in the future there won't be dedicated hardware for graphics? You mean it'll be more CPU cores and ray tracing instead? Yeah. My assumption is that either everything falls apart and they can't keep making things faster, which could happen, or if they keep figuring out ways to like make better CPUs, eventually the GPU cores will just collapse into CPU cores and we'll just have a many core machine, and that'll be that. And so like, yeah, maybe you still have OpenGL or something, but it's OpenGL that's just implemented on those cores, but you could use them for something else. It's already very close to that. It just needs to take one big industry consolidation phase for that to like become a reality. And so it won't necessarily be ray tracing, it could still be rasterization, but it would be rasterization on cores that are basically CPU cores. And maybe there still might be core types in the sense of like what their cache is optimized for or how their memory is optimized or something. There might be certain things that still change. Like there could be in order and out of order cores or something like this. But in general, they'll still be programmable pretty much completely, is my guess. All right. Would you think in the next 5 to 10 years they'll move us from 64-bit to 128-bit? Dude, they're already 256-bit. Intel x64 processors are now 256-bit. And we're using 128-bit registers on the stream already. But yeah. All right, I'm going to wind it down. Wind it on down. You know what I'm saying? Little wind down. The old wind down. Alrighty. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can play around with it. Definitely check that out if you're interested in experimenting or doing whatever sorts of crazy experiments you have cooked up. Don't need to know about it. Whatever you do, you know, like if you want to do some weird things with source code, that's between you and the source code, right? Anyway, we also have a forum site. You can go to ask questions or get an annotated episode guide. We have a Patreon page. The Patreon page allows you to pledge to the video series. If you just want to support the video series, that's the place to do it. We also have a tweet bot that tweets the schedule at you and little reminders during the day. If you want to catch the stream live, it helps you know when that's going to be. So check that out if you're interested. And speaking of that, we will be back here next week on Monday to finish up our Viz code. We got a couple days worth of work to do to make some nice debug Viz stuff there, so that's what we're going to be doing. So I hope to see you back here for that. And again, check the tweet bot if you want to know the exact time for Monday, because the schedule will get posted sometime this weekend. So that's it for today. Have a good weekend, everyone. I'll see you back here on Monday. Until then, where's my thing? Have fun coding, and I'll see you on the internet. Take it easy, everyone.